Hey folks, this is a video dealing with the ambiguous triangle and what you need to do to be able to solve it. So first of all, let's remember that the ambiguous triangle is the one where I know two sides and then I also know an angle that is not between the two sides. A really easy way to point that out, or an easy way to remember that, is if my angle has the same name as one of my sides. So since here in this particular example, I've been given angle A, but I also know what side A is, then I know that this is going to be an SSA triangle. So let's go ahead and fill in some things on this picture. Notice that I have drawn a couple things already on my picture. This side, I don't know the length of it. That's why I put an arrow there, because I don't know how long it is. So that's going to be my side C, because that's the only side I don't know. And then that would mean that this side has to either be side A or side B. I'll talk about that in just a moment. The only angle that I have on here is this angle right here. And so since I know angle A, we'll call it angle A. Well, side A has to be opposite angle A. So that means that side A has to be over here somewhere. Please understand that that green dashed line that you see on the screen, that is not side A. I have not drawn side A because I'm not quite sure where to draw it. That green dashed line represents how high the triangle is. So it's the height of the triangle. But I know that side A is somewhere opposite angle A. So it could be here, it could be here, it could be over here or over here. There's all kinds of places that side A could be. I just don't exactly know where it is, so I haven't drawn it yet. The last side that I know is side B, so this one is going to be side B. Now, let's call that green dashed line H, standing for the height of the triangle. And since the height forms a right angle, this actually is a right triangle at the moment. Again, I don't know where side A is, but it's a right triangle at the moment. And so if I were to use SOHCAHTOA, I would be able to say that the sine of angle A is going to be the height divided by side B. And what I would like for you to do is to get H by itself. And if you get H by itself, H will equal B times the sine of angle A. And this right here, the reason I go through all of this is going to be something that you're going to use over and over again here in just the next few moments down in the chart below. So every time I see the height in the chart below, I'm going to replace it with B sine A, because those two are equal to each other. The height is equal to B sine A.